So in our video, what we are going to be talking about is we're starting a new chapter, chapter 3, and chapter 3 has two things in it, probability and trigonometry. So today what we're going to do is we are going to talk about probability, okay? So what is probability, right? It is basically it's the measure of chance that a particular event will occur. That's what probability is, right? It's a chance that a particular event will occur. And today what we're going to focus on is we're going to focus on how we can set up our area model, okay? Which we have been using from previous classes, okay? We have something, you might see this eventually, called sample space. So that is just all listing all the possible outcomes of a particular situation, and that's called a sample space. So for instance, if I flip a coin, right, then my sample space is going to be heads or tails, right? So I have two sample spaces. If I roll a dice, right, so let's just say a six-sided dice, that means my sample space is 1, 2, 3, 4, 5, 6. I have 6 different things that can possibly possibly come up. Okay, so how can I kind of use that information with an area model? Okay, so here's the first problem. So it's in the genes, right? So can you bend your thumb backwards, right? Or do you have the ability to make your tongue be a U shape, right? So again, if you think about it, for your U shape, you only have two possibilities, right? Yes or no, right? Yes, you can do it. No, you can't, right? Can your thumb go backwards? Again, yes or no. Those are our only two sample spaces, okay? So when I'm setting up our area model, right, I want to represent those two things. So if we continue and it says, assume that half of the population can bend their thumb backwards and that half can roll their tongues. We also want to assume that these genes are independent. So whenever you see that word independent, right, it just means that it does one, not gene, just one thing, does not affect the other one, right? So it doesn't affect the other one. So again, rolling my dice doesn't affect how I flip my coin or vice versa, okay? So how I would set up my area model would kind of look like this. I am going to say that I have two things to look at. Can I bend my thumb? And again, two possibilities are yes and no, okay? Can I roll my tongue? And again, two possibilities, yes and no. I want you to notice that if you add these two fractions together, 1/2 plus 1/2, it will give you 2/2, which will give 1. And 1 in terms of percentages, that's like 100%. That means everybody's going to be able to answer 100% of the time to say, yes, you can bend your thumb backwards, or no, you cannot. Okay, and same thing with rolling your tongue. If you add the two numbers together, it's 1. So if you think about it, your box is really an area model of 1 times 1, which means all of these boxes are going to multiply to 1. So you have a 100% chance of getting something in this box, right? So how do we actually find that number, right? So we're going to multiply. We're going to multiply 1/2 by 1/2. So I'm going to get a fourth, or AKA 25%. And then this is also a fourth, or aka 25%. This is also a fourth, and this is also a fourth. Okay, so if I think about this, I can say based on my probability, I can say my probability of bend thumb and roll tongue, right? So I'm looking at, yes, I can bend my thumb. So yes, I can bend my thumb, and yes, I can roll my tongue. So where do I have yes and yes? I have yes and yes in this box. So that means I have a 1 in 4 chance of being yes and yes, or AKA I can say 25% chance. What happens though if it's not all the same? Okay, so what happens if we continue reading down and I see that it is 1/4 of the population can actually bend their thumb backwards? Okay, so let's create a new box and let me outline or fill it. Let's make that blank, right? So, okay. So again, I'm going to create my box. And again, I'm just going to say thumb up at top. And again, I still have two possibilities, yes and no. But this time, my thumb, such as the ability to bend backwards, is only 1/4. So that means that this guy would be 1/4, which means that there are 3/4 that cannot. So I put 3/4 right here, and notice that 1/4 plus 3/4 again equals 1. And then I can do the same thing on my area model over here. So I'm just going to say this has to do with your tongue. Okay. And again, my two possibilities are yes and no. Okay. So this time it turns out that less than half of the population, or a lot more than half the population, can roll their tongue. So I will change this to a 7 out of 10. And notice here would be 3 out of 10. So again, notice that 7 out of 10 plus 3 out of 10 still gives us that 10 out of 10, which gives us that 1. So again, I can fill in this box. So 1/4 and 7/10. So this would be 7 out of 40. This would be 21 out of 40. This is 3 out of 40. And then this is 9 out of 40. Again, if you add up all these numbers, 21 plus 9 is 30. This gives you 37, and then 40. So again, there's a 100% chance that you will roll, or it's not roll, sorry, you will end up in one of those boxes. Okay, so let's create our own, let's create another one. So let's talk about blood types, okay, that can be affected. Okay, so Zach and Nick are shipwrecked on a desert island. Oh no, and Zach has been injured and is losing blood rapidly. Nick is the only person around to give him a transfusion. Okay, there are 4 different types of blood that can be found: O, A, B, and AB. Okay, 45% have O blood, 40% have A blood, 11% have B, and 4% have AB. Okay, so what we want to do is we want to figure out kind of what is the probability that all that Zach and Nick can be okay. All right. So again, what I want to do is I want to draw a box. I notice that Zach, right? So Zach, oops, change marker. So Zach, right, has 4 possibilities for blood. So if I create a giant box, right, he could be an O, he can be an A, he could be an B, or he could be an AB, right? And then, if you think about it, boop, 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 Nick also has 4 possibilities. He can be an O, he can be an A, right? He could be a B, or he could be an AB, right? Now, we want to make sure that we use our percentages. So I'm going to change percentage to a decimal because it'll be easier to multiply. So this would be your 45. So this would be 0.45 now. A is 40%, so we're going to say 0.40. So I'll put 0.40 over here. If Zach is B, he's at 0.11. And then AB is 0.04. So that's really small. Again, if you add up 45 with 40 plus 11 plus 4, there is 100% chance that you are going to be one of these 4 blood types. So what we want to do is we want to use a calculator, and we're going to multiply some of these numbers together. So if you end up multiplying 0.45 with 0.45, 0.40, and fill in all of these charts, right? Here's a better looking chart for you. Again, you can leave them as decimals. If you want to turn them back to fractions, you can. But these are what all your numbers are. So here's what Nick and Zach's numbers are. Notice that for OO, it is the best 20%, 20, or should I say 20.25%, and AB is the worst. Right? So what can I do with this information? So what happens if I wanted to know about this question, right? What's the probability that Zach and Nick have the same blood type? So probability, I'm just going to say same blood. right? So that means for his to have the same blood, right, I'd be looking at this box, OO. I'd be looking at this box, AA, this box, BB, and this box, ABAB. So again, I'd be counting up OO plus AA plus BB plus AB, AB. So again, if I write all of these numbers out, right, I am going to get what? 21 and 0.116. So the probability that they will have the same blood is about 37.62%. Now that doesn't seem too bad. I mean, it's either that or he dies, right? So again, these are your same blood, right? But lucky for these two people, you actually don't need to have the same blood, right? Other bloods work with everybody. O is universal, so O can go to A, it can go to B, it can go to AB, it can go everywhere, and A can go to AB, B can go to AB, and that's it, right? So if I look at this again, and I say compatible blood. This time, what I'm looking at are these boxes. So OO is still compatible, but O can give to A, so I want to look at that box. O can give to B, and O can give to AB. Now, A cannot give to O, right? So A can only give to itself and to AB. B can only give to itself and to AB. And unfortunately, AB is stingy and only wants to give to itself, AB. So these numbers, again, OO, OA, OB, OAB, and then AA, AAB, BB, BAB, and then AB, AB. So if I add up everything that is highlighted, so 25.25, or sorry, 20.25, 18, 4.95, 1.8, add that with the second column, and the third column, and the fourth column. Oops. We're going to get probability is going to be, so compatible blood, I'll just rewrite it again, is going to be 64.41%. Now that is a lot better than the first one, right? So again, it's just a little bit better. All right, so that's how we set up our area model, okay? So again, we can put percentages in there. We could have said that this was 45 out of 100, right, who get the blood, right? So again, we can leave it as fractions if we want to, or change it to decimals, or we can look at it as percentages. And that's how we focus on area model.